Very good morning, dear students. I hope all of you have understood the various terms in psychrometry like dry bulb temperature, wet bulb temperature, dew point temperature, as well as the psychrometric chart. Now, today we are going to see the important air conditioning processes, namely psychrometric process, various processes happening like cooling, heating, humidifying, dehumidifying. All these things will be discussed with the help of a psychrometric chart. So first one is sensible cooling. So what is the difference between latent heat and sensible heat? You know that latent heat is the heat required to change the phase of a substance, heat to be absorbed or rejected when the substance changes its phase. Similarly, sensible heat is the thermal energy or heat required to change the temperature of a substance within the same phase. If it is liquid, suppose you want to change the temperature of water from 20 degrees Celsius to 30 degrees Celsius, the heat required is sensible heat. So from that word, this process came into usage, that is sensible cooling. So there is no change of phase of the substance. So you can see here in the psychrometric chart representation, OA is the process. Process OA is the process in which the temperature, dry bulb temperature reduces. Dry bulb temperature reduces, the moisture content of air remains constant, because in the psychrometric chart you know that a horizontal straight line represents a constant specific humidity process, because on the y-axis you have the specific humidity or humidity ratio or simply humidity, omega or W, right? But the temperature at the same time decreases because the direction of the process is from right to left. So OA is a representation of sensible cooling on a psychrometric chart. The initial enthalpy is HO and the final enthalpy is HA. So enthalpy, obviously, when the temperature decreases, will reduce. So moisture content of air remains constant, but its temperature decreases as it flows over a cooling coil. So if you want to have a sensible cooling process in an air conditioning system, you should have a cooling coil. So obviously there will be some cooling effect will be produced as water spraying or something else. We will see the air conditioning processes with the help of the different components in the coming classes. Second process is sensible heating. So it is accomplished with the help of a heating coil where the moisture content remains the same in the air, but at the same time the temperature increases. The temperature of the air increases. So this process is represented by a horizontal straight line OB on a psychrometric chart. Cooling and dehumidification. So this is the process of reducing the temperature, cooling, and dehumidification, removing the excess moisture content from the air. So when the moisture is cooled below its dew point, you know what is dew point temperature. If you have any doubt, please refer to the previous class. So when the moisture is cooled below its dew point by bringing it in contact with a cold surface, I will show you the diagram. Some of the water vapor in the air condenses. So condensation happens. So during condensation, obviously, a cooling effect will be produced. So water vapor will condense. So dehumidification, removal of moisture content from the air also happens. So as a result of this reduction in temperature as well as the condensation, both the temperature and humidity ratio decreases. So you can see here this arrangement, there is a cooling coil, okay, and there is a collecting filter kind of arrangement where the excess moisture from the air will be removed. Suppose if you want to remove the humidity of the air in a very humid climate, in a very hot and humid climate, you need to adopt this method of air conditioning, cooling and dehumidification. So this is a representation of that process on a psychrometric chart OC, you can see here, this is the process. So this is not a horizontal straight line. If it was a horizontal straight line, it was simply cooling, sensible cooling. Since it is a slanted line OC, it represents the cooling as well as dehumidification. The specific humidity reduces from W0 to WC. I hope it is clear. Next one is cooling and humidification. So in a dry climate, you may have to add moisture content to the water along with cooling. So air temperature drops and humidity increases. So reduction in temperature at the same time increase in humidity or moisture content in the air. So this process will be represented by an inclined line on a psychrometric process like this. OE line OE represents the cooling and humidification process. The humidity increases and temperature decreases, where the cold water is sprayed onto a wetted surface. A cold water will be sprayed onto a wetted surface. Now the next process, psychrometric process, is heating and humidification. So obviously you know that the temperature should be increased in cold countries and water content to be added, especially in a dry climate. So sensibly heating the air as well as adding water vapor to the airstream through steam nozzles. I'll show you the diagram. So it is usually done in winter. In winter climate, you need to have hot air coming out of the air conditioning system, and you need to humidify the room air for comfort conditions where the humidity is low. The surrounding humidity is atmospheric humidity is low. So there will be steam nozzles like this. So steam, it is the water vapor at a higher temperature. So both temperature as well as the moisture content will be added to the air before it leaves the air conditioning system like this. So initially there will be a heating coil in order to make the temperature to the desired value, and thereafter the steam nozzles will be provided that will adjust the temperature again further along with the moisture content to the air, and that will be delivered from the air conditioning system through the ducts. And this is a representation, OD is a representation of the process on a psychrometric chart. Heating and humidification. Now heating and dehumidification is sometimes preferred, and that is achieved by a material known as hygroscopic material. Hygroscopic material, which absorbs adsorbs the water vapor from the moisture, which absorbs or adsorbs the water vapor from the moisture. So it can be, the hygroscopic material can be solid or a liquid. The speciality of the hygroscopic material is given in the first sentence, that is the adsorption or absorption of water vapor from the moist air. Okay, so that is that process, that absorption of water by hygroscopic material is an exothermic reaction. As a result, the heat will be released. Exothermic reaction, heat will be released out, so which is transferred to the air and enthalpy of air increases. So both will be simultaneously happened, heating as well as dehumidification. This hygroscopic material, when incorporated in the particular component in air conditioning system, that will remove the excess moisture from the air. At the same time, as a result of this absorption of water moisture from the air is exothermic reaction, heat will be released. That thermal energy or heat will be added to the air so that we will get a hot air at the outlet. So this is a summary of various process what we have seen so far: sensible cooling, sensible heating, humidification, dehumidification, cooling and dehumidification, heating and dehumidification, heating and humidification. So all these lines are drawn like this. These are the general representation of various psychrometric processes in a nutshell within a psychrometric chart. You know that psychrometric chart is having dry bulb temperature on the x-axis, humidity ratio or specific humidity on the y-axis, and the left-hand side is bound by the saturation line. So we will meet with another interesting session in the coming class. Till then, goodbye. Thank you for watching.